Dear students, in the last two classes, we have seen the various braking methods for induction motor drive, in which we have studied about the regenerative braking, plugging, and the dynamic braking. One part of the dynamic braking is AC dynamic braking, which we have studied in the previous class. Now, the second part of the dynamic braking is the DC dynamic braking. The DC dynamic braking is obtained when stator of an induction motor running at a speed is connected to a DC supply. Here there are four circuits are made here, in which this is the star connected winding and it is for the star connected winding and two for the delta connected winding, in which the two phases are connected to a DC supply. Any two phases are connected to a DC supply. In connection A and connection D, the only two phases are used for the connecting the DC supply and one phase remaining left. And connection B and C, two phases are connected to a DC supply and remaining two phases are connected to each other. On basis of that, there is a two types of connection are there: two lead connection and three lead connection. Connection A and D are known as the two lead connection, while connection B and connection C are known as the three lead connection. Here is the circuit how we can generate the DC supply and give to the stator of induction motor drive. Here there is a single phase transformer which takes the supply from any two phases, and there is a rectifier circuit. From the rectifier we can take the DC supply which can be connected any two phases. When we connect the DC current, we flowing the DC current in the stator, which produce a stationary magnetic field. As the nature of DC supply, the stationary magnetic field will produce motion of rotor. In this field induces voltage in the rotor winding. Machine therefore works as a sink generator, and generated energy is dissipated in the rotor circuit resistance, thus giving the dynamic braking. This is the concept of the dynamic braking. How, what effect, what procedure will be followed when a DC current will be flow and what phenomenon will occur. So this is all about the DC dynamic braking. Next method of dynamic braking is self-excited braking using capacitor. In this method, three capacitors are permanently connected. Here is you can see three capacitors are permanently connected across the motor terminals. Values of capacitor is so chosen when disconnected from the line, motor works as a self-excited induction generator. This in this circuit we can say that this is the induction motor and this is a circuit breaker. When we connect this disconnect this circuit breaker, the permanently connected capacitor makes it operates in the self-excited DC generation mode, self-excited induction generation mode. So this is the operating characteristic for this induction generator. Characteristic A and characteristic, this is a characteristic A, characteristic B, and the intersection of both the characteristic is point C is the operating point. Characteristic A is the no load magnetization curve of induction motor, while characteristic B is the represent the current through the capacitor. The current through the capacitor can be expressed in the form of IC equal to root 3 E upon XC, where or root 3 E omega C, where C is the capacitance of the capacitor, while E is the stator induced voltage per phase. This capacitor supplies the necessary reactive current for the excitation. So the operation occurs at point C. As the speed falls, the operating point C shifts downward. You can see this is small a, small b, and small c. This is the operating point C. After some time, when the speed falls, a condition will occur when both the curves are failed to interact and machine therefore does not self-excite and braking torque falls to 0. So this is the condition where the machine torque will become 0 and braking condition will occur, and this is the characteristic for the speed torque characteristic for this mode. So this is the all about the self-excited braking. Now next method is the zero sequence braking. In this braking, three stator phases are connected in series across either a single phase AC or DC. This is the circuit diagram for zero sequence braking, where all the three phases are connected in series with the AC or DC supply. So such a connection is known as zero sequence connection, because we have already stated that in case of zero sequence supply, the phase sequence or phase difference will become zero, or the current in all the phases or all the winding are co-phasal. As when we connect all the phases to a single phase AC or DC supply, the number of turns will become 3 times. So the MMF caused by the co-phasal current produces a magnetic field having 3 times the number of pole for which machine is actually wound. What effect will occur when AC or DC supply is connected? The main effect is that the field will become stationary. With an AC supply, resultant field is stationary in space and pulsate at the frequency of supply, while in case of DC supply, resultant field is stationary in space and is of constant magnitude. So speed torque curve for both the cases are shown here. This is the characteristic for the AC when we connect the AC supply, while this is the characteristic when we connect the DC supply. When we connect the AC supply up to the one third of synchronous speed, we can use as a braking mode. After this, it is come in the motoring mode. And in case of DC supply, entire range can be used as a dynamic braking mode. So with DC supply, with AC supply, braking could be used only up to one third of synchronous speed. However, braking torque produced by this correction are considerably larger than motoring. Essentially work in the regenerative braking. With DC supply, braking is available in the entire speed range. So this is all about the braking method for the induction motor drive. So here the braking method has been completed with this lecture. In the next lecture, we will discuss about the various speed control method.